Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's Security Boulevard webinar. I am Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your question. And we will try to get to as many questions as we can before the end of today's webinar. Also, at the end of today's webinar, we are doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is there's an OpenBullet attack configuration for your site. What now? Our speaker today is Will Glazier, who is Head of Threat Research at Cequence Security. Hey, Will, thanks for joining me today.
Hi, thank you, Charlene. Thanks for the intro.
Great.
Thanks everyone who's on the line. Thank you for joining. Hope this will be entertaining and insightful for you. Like Charlene said, my name is Will Glazier, and I'm in charge of threat research here at Cequence Security. I've been working at Cequence for a little bit over 5 years now. Today we're going to go through a presentation that's going to be pretty focused on one of the most popular attack tools that's used out there. This is kind of one of the bread and butter starter kit for attackers looking to do credential stuffing and account takeover, and some of the most common attacks that we see, that we're stopping out in the wild. So here's our agenda. We're going to dive right into it, go into OpenBullet itself, what it is. We're going to take a look at it, dive into the capabilities of the tool. We're going to talk about the motives behind it, like what certain things are designed to do and what a typical attacker playbook would be. And then we'll go through some steps to be proactive, right? From the threat research perspective, what can you look for online to see if you might be getting hit by this tool? What are some indicators you can go to right now? And then obviously, what do we do at Cequence to stop these kind of things? And then it'll be followed by a Q&A. So who are we and what do we do? Cequence has been working in the space of bot detection and bot mitigation for a while. We're an application security company that's focused on the kind of problems that come from these bot attacks. Those can be account takeover, credential stuffing, content scraping, content theft, romance scams. It really, the fraud depends on your business, but a lot of times the bots are aiding and abetting that fraud and actually enabling it, carrying it out. So that's the technical problem we're solving, and we're solving it across all different application channels, like your web properties, your mobile app properties, and your API-based applications. So that's really powerful. We're doing the detection the same way on all those channels. Pretty important. So go ahead and give us a look on our website. And with that, I'll end the obligatory intro slide, and we'll dive right into OpenBullet. So what is OpenBullet? For those of you who haven't heard about this tool yet, it's what I would call an all-in-one attack toolkit that can be used for account takeover, credential stuffing, and other kind of bot attacks. What's unique about this tool is that it makes it really easy for new users, for people who don't have programming skills, to get involved and use this tool. It's sort of like democratizes the use of account checking, makes it really easy for low skill actors to operate, but also offers enough flexibility to allow those higher skilled actors to still use this tool. This is an open source version of the older BlackBullet tool that was created back in 2018. This tool came out in March of 2019. There's a pretty up-to-date and well-maintained GitHub repo and forum where issues are raised, bugs are tracked, people are contributing to this project because it's built as a web testing platform, right? A tool that you can use to do pen testing or application testing or whatnot. Like a lot of tools like that can get repurposed and misused for bad purposes. So that's what we've got a link to the OpenBullet GitHub repo if you want to go check that out and look through some stuff. But most importantly, so now we know what the tool is. We want to talk about what it can do. So the title of today's webinar was, there's an OpenBullet config for your site. What do you do about it? So a config, what that means is it's instructions for the tool to attack your site in particular. There's a market for configs out there. Some configs are sort of given away almost for free to build street cred for certain developers. But you'll purchase a config oftentimes, for a few dollars, $10, $15, or even less. The configs are highly configurable and customizable, and you can, like any sort of like any old popular video game in our heyday, there's tons of plugins and mods built by the community that you can sort of plug into these configs that add some interesting capabilities that we're actually going to go through in a second in the tool. A lot of times, for those of you who delve into the details, you'll see two broad families of config files. You'll see what's called lolly files, which is like lolly script, the scripting language inside the tool. That's kind of the core, the original tool. And then you'll see this anomaly version that I have in the third bullet point on the lower left there. And that's one of the newer modded versions of this tool with some more robust capabilities. And those text files will come with those two abbreviations at the end, .lolly or .anom. We'll go into tricks you can do on Google to try and see if files like this exist for you out there. But capabilities here on the right-hand side, some ones that resonate with people tend to be things like reCAPTCHA bypass. This tool comes with built-in support, links like API connectivity to about 11 different out-of-the-box CAPTCHA solver solutions. You can use Selenium drivers in this tool, execute JavaScript, do human browser actions, and tons of different custom functions that you can basically script. Or if you're more of a noob, you don't have to actually script them. You just click a few buttons and use what other people have created. So with that capability slide, we're going to just hop over to the tool itself and walk through some of those things that I discussed. So here's the original sort of OpenBullet version 1.2.2. And what I've got, I'm actually going to do this. I'm going to do a cooking show style here. I'm going to put the attack tool in the oven here. We're going to start an attack, and as that's running, I'm going to walk you through the different components of the tool. We'll come back to the defense side in a little bit. So the first thing I mentioned was configs, right? The attackers need instructions for the tool to go about carrying out this attack. So I've built a really simple set of instructions here to attack a demo site that we've set up. And this tells the tool exactly what to do in what order. And so you can see the blocks here on the left really tell the tool exactly in what order to do things. The first request I have, I'm sort of initializing a session just like a normal user would. I'm hitting sort of the home page or the landing page for the login, right? And then what I'm doing, for example, is parsing out a bunch of session cookies that identify me that I want to reflect back to the login. So essentially, my requests look valid. Okay. The next thing I'm doing a function here that is going to, in this case, generate random user agent strings. That's a commonly spoofed field by attackers. They'll try to generate. They'll code in a user agent string that looks like the latest version of Chrome, or they'll randomly rotate through unique user agent strings to try to bypass defenses. There's a ton of different functions that you can go ahead and use in this tool, and I just chose kind of a simple one that a lot of people probably experience. Now, the next green block is the actual login request. This is where we're reflecting back the session cookies we just got. We're sending in the usernames and passwords that we want to take over. That's the important part here. We're sending in the credentials to take over. And And then the final instruction is we have to check what succeeded and what failed. We have to see, okay, the green thing here, if I get certain cookies in the response, or if I get a response with rewards points that are greater than 0, then I've successfully taken over an account. If not, consider it failed and toss it out. With respect to the capabilities I just discussed, we'll just walk through this, pretend I'm adding a new block or I'm building a new config myself. This is where you can see a lot of these other capabilities that exist in this tool. Like, for example, CAPTCHA solving. If I added a block that would do that, for example, you can see that there's the type of CAPTCHA that I'm faced with here, right? Some of the newer reCAPTCHA versions, HCAPTCHA 2, for example. And then there's, you would go about finding the site key and URL in the DOM, and you can send the requests through to a CAPTCHA solving service that you've actually plugged in. That section is in here in the settings. You would select which CAPTCHA solving service you use, plug in your API keys, and if you have if you have credits there on that site, you'll go ahead and be able to bypass some of those CAPTCHAs. So the config section, this config builder right here is what makes it easy for attackers to develop the tool, even if they don't have scripting knowledge, right? They just have to be able to go through the website like a normal human would and understand what requests they need to make to get through to the login page. The second most important component of an attack is proxies. The attackers need to distribute their attack across, in an ideal world, if they're going to try and take over 100,000 usernames, they want 100,000 different IPs so that it's really hard to detect. So the proxies section is where an attacker uploads all of the proxy IPs that they want to hit, that they want to route their traffic through. So what I've done is I've hit the easy button and I just imported a bunch of free and cheap proxies into this tool. Okay, importing is as easy as copying in a file or pasting in a bunch of IPs. The more advanced attackers will link up to what we call bulletproof proxy services through an API, and that's where instead of plugging in an individual host and a port name for a proxy IP address, they'll plug in a connection to some of the most popular bulletproof rotating residential proxy services like, Illuminati or Smart Proxy, for example. And the host, inside the host, they're actually choosing what country they want to send traffic from us.proxyservice.com on port 10,000. And then that service takes care of rotating through hundreds of thousands of unique IP addresses. So the proxies get imported in this section, and you can see I actually can check which ones work and which ones don't by clicking this button, and the tool will check for me. And then while that's running, I would go ahead and, the third most important part of my attack tool is to upload the credentials I want to take over, right? This is where the data breaches that happen every day come into play. Attackers get a hold of a zip file or a text file with 1 million credentials, and all they do is just drop it right in here. Say, yep, I'm, taking over credentials. Obviously, word lists can go beyond the types here are super configurable. So I could carry out attacks beyond credential stuffing, but today we're going to focus just on credential stuffing. So I plug in my credentials here, and then it's basically ready to go. So, before we launched that attack before we started, we're going to go check out what that looks like in the bot defense later on in this webinar. But first, I want to hop back to our slides and talk a little bit about, relate a little bit about what we just saw to the attacker outcomes, their goals, and then how we use those outcomes and goals to aid our detection. So executing that attack, right? When I clicked start in OpenBullet and watched that meter grow, what was going on? In reality, the tool was, the OpenBullet itself was executing an attack that leverages sort of these four main components of the attack. We needed a tool, which is OpenBullet and is the configuration file that's the instructions. We needed that to know what pages to hit and what data to send in. Moving clockwise through this chart, we needed proxy infrastructure to distribute and anonymize our attack, right? We saw that tab there. Behavior. We needed, the behavior that we programmed into that config file. We needed to behave like a human. So if I needed to do even more sophisticated stuff like execute some JavaScript or bypass a CAPTCHA, I would plug that into the config so that I would behave like a human and go to the appropriate pages that a human would go to. And then finally, in the lower left, you saw the word lists tab where we enter in all of our credentials. So again, easily sourced, regularly refreshed, and data breaches happen like just as sure as the sun sets in the west kind of thing. So that's what those different components of OpenBullet are doing. And if we frame our defense in the context of these four pillars, we can actually gain a little bit of insight into the attack and help ourselves defend. So with that in mind, we're going to back it up a little bit to the attacker goals. So we've gone through what exactly they're doing from a technical perspective. Now, what are they trying to get out of this? So common use cases of OpenBullet, the most common is credential stuffing. It's called, you'll hear different terms for it, account checking, account cracking, brute forcing even. And, all of these attacks are very similar. In these bullet points here of how to perform an ATO attack, we're walking through kind of a common workflow of first you got to do a little bit of recon, right? And the recon is typically manual, where I have to figure out what pages I have to go to and what I want to plug into that config. After the recon is where the attack strategy comes in. There's credential stuffing, which is a problem that's ongoing because us humans reuse our passwords, right? We use the same password across different sites, and that problem's not going away because people aren't changing, right? So that's the strategy of I get a word list of 100,000 different credentials with different usernames and different passwords, and I just try them. And if I get 0.1% success rate, out of 1 million credentials, boom, I got, 1,000 accounts that I just took over. The second one would be more of a brute forcing approach, credential cracking. What that means is you're not relying on a user to reuse the exact same password, but maybe you'll plug in some, dictionary attacks or some kind of common password guessing along with those usernames that you've received in the data breach. Brute forcing can also take place on, a single account, and that's more of the typical old school brute force type attack. There's a third type of account takeover that's become more prevalent recently and is more of a concern when we think about enterprise account takeover, and that's what we call password spraying. And if you think of the logic of credential stuffing, or actually if you think of the logic of username brute forcing, and you just invert it, it helps understand that password spraying is really, we know what are the most common passwords used by people in the world, right? Password 123, stuff of that like putting in 3s instead of E's, right? I'll take those common passwords and then do a little bit of recon on a company and understand what's their email structure, right? Is it first.last@company.com? Is it just first name? What is it? And then I go to LinkedIn and I crawl through every employee, find all their names, and I try the top 100 passwords with every email address on a login portal and see if I can take over accounts that way. So the common thread between all these kinds of attacks is this bottom bullet point here. They've got to use those four pillars that we talked about on the last slide. They have to use proxies to anonymize and distribute their attacks. They have to use config files to tell the tool where to go. And the behavior that shows up out of those characteristics is very, very similar, even though and it's similar because the goal is the same, in this case, to take over accounts. ATO goals. So this is kind of from a defender's perspective, how much pain can this cause, and how much money, can be lost. In the, the second bullet point here, when we talk about fraud and just dollar loss, we've worked with a couple of our customers to understand what their cost structure is for, like, hey, if you lose an account, and $1 of rewards points is lost, how much does that actually cost your company? And it's fascinating for us to learn that, like, that $1 in loss is actually equivalent to maybe $3 in expense, because they have to, it's the, the time that's lost and used by the customer support team that has to respond to the inquiry of the customer saying, hey, my rewards points are gone. It's the dollars they have to refund that customer. And then it's also the dollars that they lose in potential future revenue due to the brand, due to a little bit of a hit to the brand, and maybe that customer no longer becoming a return customer. You can see the number of sort of total losses from ATO in 2019 from this Javelin report, about $4 billion. And what we've noticed is that these attacks have some trends. During special events, like, the Black Fridays of the world, if you have a big, like, start a summer sale on Memorial Day, that's when bots will tend to show up. They know that the larger the haystack grows, that they can fit in 100,000 and 1 million needles, and they'll still get through, right? We see among these attack trends that these config files we're talking about, when we see new ones pop up on the internet, we will frequently, right after that, see a lot of testing and recon using those same tools. The lower level attackers who maybe are just plug and play, they want to just use tools that other people have made, we'll see them try those right away, and it will increase dramatically in volume. We also see attacks increase after new big data breaches, right? Because that third pillar of credentials, there's more credentials for people to try. And then finally, we notice that, attackers understand how companies work, and they understand that, some companies may be, a lot of times we're all stretched thin, right? And we have a lot to do and not enough time. Off hours, weekends, and holidays, they understand that maybe you have fewer people working in your stock at that time. Maybe the guard is down a little bit. And maybe you don't have the resources to, like, play whack-a-mole that you may during the 9 to 5 hours. So they'll just not show up during 9 to 5, and then they'll come later on, as soon as people are leaving work, kind of thing. So attackers know those details, and they'll try to exploit them, while they're trying to accomplish their goals. So I've walked through a few different techniques, and I think there's different levels of sophistication that we've talked about with some of these different techniques. And with this slide, we'll kind of try to bucket these actors so you can understand maybe which ones do you have to be, which ones can you consider low-hanging fruit that will be easy to knock off the radar? Which ones do you maybe need to be concerned about as far as them taking up time and resources? And then which ones do you need to be concerned about that may actually be sort of slipping under the radar and actually causing damage? So the script kiddies on the left would be folks that they could use tools like OpenBullet, right? Because it's really easy to get this tool going. But what's going to happen is they're going to be primarily taught by, like, YouTube videos. They're going to be watching tutorials of other people. They're going to be taking config files that already exist and plugging them into their tool and just pressing play on 20 different configs at once and seeing what shows up. That's a feature of OpenBullet. You can parallelize these attacks, so you can attack 20 people at once. There'll be little to no recon because they're doing the plug and play attacks, right? They're not investing too much time and effort. They're trying just to hit play and see what happens. And then finally, they're going to use cheap and low quality proxies. So for today's demo, the proxies that I imported into our test from, like, common proxy websites like Proxy Scrape, that's the kind of proxies they're going to use and upload because it's free. All it requires is you to copy paste from a website, and it doesn't cost you anything. So the middle group, kind of the more organized retail crime group, are somewhat opportunistic and targeted. So we're dealing with people here who they'll see these kind of config files, and they understand more about the landscape, and they understand who might be a lucrative target, right? Who has a rewards points program that can be easily converted into cash? Who has, a gift card, portal on their website where you can check balances easily and try to take over gift cards. They'll target those kind of accounts, and they will do some reverse engineering of how the site works so that they're not engaging with the tool as simply as the plug and play style. They'll take an initial config as a base, and they'll grow from there to make sure they keep it updated with the latest versions of the apps, to make sure that they can continue to bypass any defenses, because they're running a business and their business relies on them getting accounts to take over and monetize, right? That fourth bullet down says they're money driven. These people it's purely profit motive, and they need to turn around and oftentimes sell these accounts that they've taken over or the goods that they've extracted on a forum somewhere. These actors will use more high quality proxies. They know what proxy services to use to make sure they can get through defenses. And if we think of it from a cost structure, using those higher quality proxies is it's just an investment. If they spend $20 for a month subscription to a certain service where they're guaranteed X amount of throughput, they know that $20 in return is going to mean that 90% of their requests won't get blocked, which, if you do a little bit of math, will translate into X amount of accounts that they can sell for $10 a piece, and they quickly make back their money. So it's just an investment into the attack. The far right group are the folks that oftentimes are not actually executing the attacks on your platform, right? These guys won't take up much of your time and resources from a blocking the bots perspective, but they're the ones who develop these tools, like OpenBullet, right? Somebody had to create this tool. They typically are the ones who make these configs and sell them. They're typically the ones, if they're ever attacking, they're going to be doing it really low and slow so that they really don't stick out, because they make their money reselling the config that they wrote. So of course they don't want this config to stick out. And as they grow and develop the tool, they want to make sure that whoever they sell it to doesn't, use it and get it blacklisted, but also that they keep growing it so that if somebody does get that config discovered, that they'll stay sort of one step ahead of the defenders. So now when we discuss config files and what we can do from a defensive perspective to get a little proactive, a good start is to understand what might be a little bit about what might be out there and what we're being faced with. So simply using Google goes a long way. And using Google Dorking makes your time even more efficient using Google. So simply typing in a lot of the keywords that I've mentioned today, like config, like BlackBullet, like OpenBullet, like cracking, like checking or checker, and putting quotes around those terms, that will get you a much more narrowed down result, right? Some common Google dorks like in text, which will look in the body of the result, or in URL with certain cracking forums that you know about that you want to search through. That'll allow you to understand, are the configs that may exist for your site, are they active? Are they old? If you're only getting results from 2 years ago and you've got this well under control, that's great, pat yourself on the back. But if you're seeing configs that are routinely being updated sort of every week or every month, it means you're a hot target. It means you're probably doing a pretty good business, whatever you're doing. But it also means that there's a lot of insights that you can gain from getting your hands on these config files. So where to look? Forums like the ones listed below are hot forums. They've been out there for a long time. Null, Cracked, Cracking King, and Sick Account Shop being a place where a lot of the accounts for sale, the back end, the byproduct of the ATO will be sold. Recently there's been a lot more move towards chat services, messaging services like Telegram and Discord. There'll be a lot of Discord channels where the folks who've taken over accounts will resell them. Reddit is an underestimated, underappreciated source to get some of this intel. And then, the quote unquote dark web is listed on here, but the only difference there is just a lot of times that's where if you're going to certain markets there, you'll find accounts for sale. But a lot of the intel you can gain on the clear web as well through sites that are indexed and searched by Google. So, we're going to go ahead and do a little bit of a bot defense simulation. So we ran that attack when we went over to OpenBullet, and we kind of launched a low and slow attack. We're going to go back to the tool and run another one, and then take a look in the Cequence portal and see what shows up, right? See how we're taking info from these configs and taking our understanding of the tool into defense. So gonna go ahead and go back over here and relaunch the tool. Okay, we're gonna increase the amount of bots too, which actually means we're gonna distribute and parallelize the attack. It's a way to go a little bit even sort of more fast and furious. Okay, so I'm launching this attack here, and we can see the bar. It's checking through these usernames. I've uploaded some garbage credentials, so I'm not going to take over any accounts that don't exist on our test site. But what we're going to do is go back to the Cequence portal here, and I'm going to open this up. And I've created a filter on, ignore my name there, on the login portal for this fake site. Okay, so I'm focused at looking at just the login portal, and we can see here in the last, I'm actually just going to go to the last 15 minutes as the data comes in. All right, we'll see a bunch of red attack traffic come through, and we'll see the white line grow as this attack grows, showing the bot defense working. And what we want to do is get a little bit of an understanding of the data. So I've run the attack a few times over the last hour, so I'm actually going to look at an hour window so we can analyze a larger set of data and you guys can get a better grasp and understanding. But we've talked a lot about these 4 pillars of an attack, right? What does an attacker need? So they need tools like OpenBullet, they need proxies, they need credentials, and then they need to behave a certain way. So the data that you see down here is organized to match those 4 pillars. So when we're grouping by, when we can group by the data, we'll group by a fingerprint would be an approximation of the tool. I've put a nice little label here to make it even clearer for the audience, but a fingerprint would try to identify something like an OpenBullet config. Organizations and IP addresses are pretty self-explanatory. These would be the proxy IP addresses that we're routing traffic through. Usernames would be also pretty self-explanatory. These are the usernames we've been trying to take over, right? And so, what this means is that when we look over here on the right-hand side, all of the data, let me click on this, we're going to see all of these alert triggers mapped to the same categories. All right, so I'm going to walk you through, 3 core components of the detection here that caused this to happen. You see the white lines basically automatically went ahead and blocked any IP addresses or fingerprints that were carrying out this attack. So we kind of want to understand why. And that's where, for example, inside the tools category, we can see out of these 396 requests, there's a lot of rules that triggered every single time, especially, I'm looking at these 2 right here. The first one is saying, the user agent strings they're using, that, remember how in the config file I clicked that, I had that function button that said generate random UA. Well, turns out those UAs aren't entirely random, right? If you run OpenBullet against your site, you can learn what all the default quote unquote random UAs are. That's sort of plugged in here. The more interesting and sort of robust rule is a rule that we have that's more of an ML based rule that says, this is a forged browser request. And what that means is This request, we're actually looking at the guts of this fingerprint, right? This fingerprint is it's kind of part of what makes Cequence Cequence. It's part of our proprietary, it's a little bit of our secret sauce, but we analyze the vector that makes up that fingerprint, and we say, hey, they're telling us that they're Chrome in the user agent string, or Firefox, or whatever they're telling us. But in reality, it looks nothing like any legitimate good browser. So when something like this is happening on every single request from a tool, it's a pretty good indicator that it's an automation tool and not a legitimate user. In the infrastructure component, we can see that a ton of bad proxy IP rules are lighting up like a Christmas tree. And that's, gained by intelligence, both from us crawling sources that the bad guys will use, these cheap, free, and easy ones, researching the more advanced ones, and also the network of attack data that hits all of our customers. We see the same proxies get used in many different places. In the behavior category is where things get most interesting, in my opinion, from the Cequence perspective. And what I want to do is highlight just a few rules that look at really two components of behavior that are really important. And they're the core of the tool, the attack we just ran. The first one is this account verification attempt rules. So there's a handful of rules that look for ATO behavior, right? The behavior being a bad guy got a list of 10,000 credentials, and they're trying to see which ones work, and they're hoping for 0.1% success rate. That manifests itself a certain way when you look at all the requests across the whole fingerprint. So this rule is saying, hey, this fingerprint is behaving really bad and has a lot of failed logins and ATO behavior right now. Okay. The second rule I want to call attention to is this user agent rotation rule. Okay. So in the tool, we plugged in that function that said generate random user agent string. And when we look at this pie chart here for user agents, we can see a bunch of different slices. Okay. And, if I switch to the list view here and we can look at all the different user agents, what we notice is this little number here is the number of requests per user agent string. And we notice that it's really even. They're using a lot of the same, the rotation is really even, right? You can see the slices of the bar are actually really even as well. Well, that's what this rule is designed to look at, because when the bot is generating a random user agent string, that has its own signal. And also, if one attacker is trying to generate entropy in their data and look like one human or a bunch of humans, there's one thing we know that they don't, and that is what my distribution, what my pool of real good humans look like. And I can tell you that if we were looking at a real browser fingerprint, we wouldn't see rotation that's this even amongst the user agent strings, right? There are certain browser versions and types on operating systems that are most common and get used by 30, 40% of people. It's not even rotation like this. So that behavior is really powerful. And then we see a ton of other behaviors because this was a really simple bot attack, but IP-based ATO behavior, meaning that these individual IPs, right? This attack was launched through about 20 different IPs. And all of those IPs are doing the same behavior. So the attack is misbehaving from multiple lenses, from granular IP level up to a more broad fingerprint level. Also, the key component of account takeover is you got to try different usernames. You have to rotate through and unique usernames. That's happening. And then also the usernames are being used by many different IP addresses. So that's more of a fraudy indicator that would resonate with a lot of folks on the fraud team. And you can see that if I go to the username pivot, that will become very, very apparent here. You can see that this OpenBullet is the best at hotmail.com was used 36 times by 10 different IPs. And that username itself had the same really even UA rotation. Okay. So when we go over to the mitigation screen, this is the last part of the demo here, we can see that, that these requests got blocked. Okay. And we can see why. We can configure some pretty granular protection as to how to block them. And in this case, we were just doing sort of simple IP blocking, but that entire fingerprint that we sent attacks from can be blocked as well. And we can basically set up criteria that says, if I go back to the mitigation screen and I go to the fingerprint pivot, I could say, we highlighted just two components that were really important. We highlighted this one, the model that says the browser is not known good, and you're doing lots of fingerprint-based ATO activity. When those two rules trigger, we go ahead and we block the entire fingerprint, so that if I got hold of really good proxies from Comcast or Spectrum or wherever, and I rotated through one request per proxy, I would still block the entire fingerprint. So that's sort of the quick, the quick overview of how this bot defense works using the intel from those configs. And I'm gonna head on back to our final few slides here. This slide is meant to wrap up what we just went through, the workflow that I just went through in the dashboard. You saw those tabs at the top that were discover, detect, and then defend or mitigate. The first piece, discovery, is all about automatically seeing the applications and API endpoints, like all of them, not just ones that you've instrumented with a certain telemetry, and extracting and analyzing interesting data. So in that OpenBullet config, I had plugged in, there was a form key or a token value I had to send in. And it was hard coded in my config, which shouldn't, if I was a smart attacker, I wouldn't have done that. But a lot of times dumb attackers will leave little trails behind. Extracting and analyzing that data could also be like the session cookies that I was reflecting back. You want to analyze that data and see if they're replaying or they're using too many and unique ones from the same fingerprint, et cetera, et cetera. The second bullet point is the detection. Detection is everything that we just went over, looking at those 4 pillars, analyzing the bot traffic with predefined rules and custom rules that you can make that focus on the 4 pillars of an attack: the tools, the infrastructure, the credentials, and the behavior. And then finally, the defend piece is automate some policies to block the bots. So as they retool and adapt, they can try to change their fingerprint, they can get better proxies, they can keep reconning and such, or they can attack at odd hours when you don't have folks available to look and analyze and defend. You want to have policies that have a little bit of a level of automation, like the criteria I discussed with, not known good and high level of bot behavior. Go ahead and block those fingerprints automatically for a certain amount of time while the behavior is going on. So just to wrap up a little bit, as far as takeaways, getting proactive on these types of simple Google searches can really help get your feet wet on understanding what the lay of the land is, how much of a target may you be or not. Then, understanding tools like this are really helpful to help you get inside the mind a little bit and understand exactly the different things that they're capable of, what's easy for them to do, what's, relatively, medium skill level for them to do, and then what's really hard and sophisticated for them to do. And that'll help you construct your defenses. And then finally, asking for help and advice across different industries have their own sort of information sharing groups. Vendors like us, we know a little bit about this stuff, and there's other vendors that do too. Asking for help across the community will help all of us. Defend against these kind of attacks. So, just to wrap up, we have a sort of a bot defense 30-day free trial, that product that I just showed you, the Cequence Bot Defense. We talked a lot about behavior. It was one of the 4 pillars in the attack components. It was one of the 4 pillars in the defense components, and that behavior fingerprint, the behavior component, comes without doing JavaScript injection or mobile SDKs. So that's our kind of claim to fame. And the third, and it's obviously the second bullet, it's not a black box, right? You saw there's lots of data in that portal, and there's lots of customizability for your platform. And then finally, the deployment architecture and the deployment structure is pretty flexible. It's a software-based solution run on containers. So, we have a SaaS offering. We can deploy in data centers. We can deploy in public clouds, hybrid clouds, and whatnot. We've done a lot of different work in a lot of different environments. So, with that, I think we've about, hit 45 minutes, and I think that's plenty of time for some questions from the audience, or anything from anybody else. So thank you guys very much.
Excellent, excellent. So yes, we do have about 10 minutes or so for question and answer period. So if you have a question for Will, please go ahead and use your GoToWebinar control panel and submit it. Let's go ahead and take a look at some of the questions that have come in already. How is Bot Defense different than Akamai or Shape F5?
Yeah, so great question. So to start with, I would say back on that prior slide I mentioned, no JavaScript or SDK implementation. That's a big differentiator. And because of that, we are able to do, we have the exact same defense mechanism and the exact same paradigm built into our ML models and our detections across all the channels of web, of mobile, and of APIs. So what that means is, and I would say that's also the way our product was built from the very beginning. So what it means is if you think of kind of like a stool, and I'm sitting on a really sturdy stool with 4 legs, and I got all 4 of them for my web and my mobile app where I've got JavaScript or I've got an SDK. And then I go over to a purely API channel, or I have a website that's, that's built entirely on APIs, and it's really flexible. Developers roll out new ones every other day. It's hard to keep track of my dev, my prod, and my sort of staging, and attackers can find those too. If the API channel, I have to cut one of the legs off my stool for defense, and it's the most important one of those, it just makes things a little harder to work without something you're used to. So that's a little bit of our differentiator, is we built it the same way from the beginning, not leveraging JavaScript and SDKs.
Excellent. All right. Okay, next question. What are my deployment options? SaaS, data center, public cloud? What do we got?
Yeah, again, so that one on the prior slide we talked about, it's kind of an all of the above. We've deployed in many different ways. You mentioned SaaS in there. SaaS is kind of an easy button, I would say, for a lot of customers, where you would basically route traffic from the CDN to a Cequence privately managed VPC in the same region in AWS as yours. And then that traffic will be routed back inside the Cequence VPC. It would be going through the detector to, mitigator pipeline or defender to detector pipeline that we discussed, and then back to your origin servers. So that's kind of the easy button, but there's been many different deployment architectures that we've worked with over time. One interesting thing I want to bring up about that is, in the product, you could see there was a bot detection screen and a bot mitigation screen. For those who are, who want to put their toe in the water first and try things out, the product is built in such a way that detection can happen totally passively. It doesn't actually require you to put an inline device in your network. That obviously, when something goes in line, you go through a lot more hoops and hurdles technically. Detection can be done totally passively, and the platform can connect to if you have an inline solution that you are okay with using and pushing IPs to, you can deploy it that way. So there's a lot of flexibility to get started small if you want, before you move into something more robust, because obviously when you see a lot of bots, you'll probably want to block the fingerprints that you see out there. So deployment, very flexible.
All right, let's see. Here's another question for you. Can all of my data be stored in my cloud or data center, or is there always a public or SaaS requirement?
So that all of this data can never leave your environment. We have many customers who have deployed entirely on-prem. The whole solution is on-prem. The sensor piece that senses the traffic, the detector piece that's doing that analysis and AI, and then the defense piece that's actually blocking it. And no data has to leave at all. That's the way the product ships out of the box, is no data leaving your environment. The product is pulling in intel from our cloud, right? Like the network of our other customers that are getting attacked. The IPs that a lot of our customers have opted in to send that intelligence to us. And you'll benefit from that, even if you're opted out. And obviously anything related to, we saw a bunch of usernames, for example, on that dashboard. None of that stuff is exported anywhere unless you tell it to for some reason. And any kind of concerns around, parsing and understanding, payment flows, right? We have some customers who are protecting maybe gift card or credit card flows. The product and solution is fully PCI compliant. And, credit card numbers won't be masked or stored, passwords won't be masked or stored, and nothing will be exported unless you leverage the CQ Connect to export things at your direction.
All right, great. We are about 9 minutes to the top of the hour, so we have time for a few more questions here. Do your customers find that they end up blocking legitimate traffic along with the attackers?
Mm-hmm. Great question. The false positive question is always an obligatory question. So what I would say to that is the solution. I think you saw in that mitigation screen there were policies, right? There was an idea of, when rule X and Y and Z, or X and Y or Z triggers, then block something. The mitigation with our product is very much under your control. The product doesn't ship with any, there's some pre-built templates that you can turn on if you really want the easy button, or you're trying to grapple with, like, you're getting hammered with a huge attack that's really obvious. But the mitigation is really granular and you have a lot of control over it. That this will not be a black box solution where all of a sudden you'll see a bunch of users being blocked because they enabled an ad blocker, for example, right? And you won't know why. The worst thing is something's getting blocked and you don't understand why. That's kind of unacceptable in our mind. So anytime anything happens, anytime any block, right? And obviously we're going to tell you we only ever blocked all 100% bots, but anytime any block happens, you know exactly why. And that policy, that threshold, the rules can all be tweaked to fit, to fit what might be unique to your environment. The custom rules, you can mimic a lot of the system logic, but maybe tune the thresholds down or tune them up to make it such that it's specific to your environment, and you don't have to worry so much about, hey, because this customer of Cequence's got hit with a lot of bot attacks from this place, that means I'm automatically going to be blocking those same IPs. That's not how it works, and you'll have a lot of control over what you choose to block.
All right. Next question. Let's see. What is the latency impact for being in line?
Mm-hmm. Yeah, so the latency impact, that's another great question. The only inline component, if you choose to go with the inline route, is what we call the defender. And that defender is doing both the sensing and the mitigating of traffic. So when it senses it, all it does is it makes a copy of the traffic and passes it to the CQAI, the detection engine. The mitigator is what takes data from the CQAI, the fingerprints and the IPs, for example, and it blocks or header injects or whatever, deceptively mitigates those things. Because that mitigator is really lightweight and is looking at telemetry that's been sent down from the detection engine, it has like next to no latency, like just a few milliseconds on, in that inline defender piece. The mitigator is really, really lightweight. And the capabilities of it, while lightweight, the capabilities are really robust. So latency concerns are super, super minimal, especially, and that's going back to the point we made about the lack of JavaScript or SDK integration, like that's part of the reason why we did that, is to minimize any kind of latency or user experience issue that may come along with client-side telemetry slowing down the thing. We're operating under the same premise for any kind of inline solution. Latency has to be super low.
All right, great. I think we have time for one more question here. So as it's not a black box, how much experience is needed to use your product? Is special training needed?
Great question also. So the as part of any deployment we've ever done, like training is part of what we give you, part of what you sign up for. So the training and we train you until you feel comfortable. It's not like you get 2 hours kind of thing. And there's tons of sort of manuals and help guides that we can provide you with. Our company does offer as part of the threat research team that I run, we have a service that we offer as well, the CQ Prime service, which does some of that policy management, right? But we'll do some of that for you, and the implementing new detection rules, getting really advanced, right? A lot of customers, they'll turn on the product and things work great right away, and there's kind of a honeymoon period where the bots are really easy and they haven't figured out anything else. And then as bots get more advanced, you want some help. You want some extra, you want help taking the tool to the next level. That's available as a service. But I would say that the customers who've worked with us and the folks who've invested in getting to know the tool themselves have gotten so much value out of it and have built in so much. It's so flexible that they can build in a lot of their own. They can plug in a data analysis engine or a data set that feeds into our product as well as out of our product. So to get a lot of value out of the tool, you don't have to become a master at like the Cequence UI per se. You just have to understand what are the most efficient ways to leverage this tool, the most efficient rules that you want to work with, the most efficient policies. And that's what we're also here for, is to help you with that.
All right. Well, we are about 3 minutes to the top of the hour. So unfortunately, that is all the time that we have for question and answer period. If we didn't get to your question, I apologize, but please know that the folks at Cequence will be getting a copy of all of the questions that came in. So I'm sure somebody from their organization will be more than happy to follow up with you offline to get your question answered. Also want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the Security Boulevard website. So you can always go look for it there. Just go to securityboulevard.com/webinars, look in the on demand section, and it should be right there waiting for you. All right, I also mentioned at the top of the hour that we would be doing a drawing for $25 Amazon gift cards. So without further ado, let's go ahead and do that. Our first winner today is Garrett S. Congratulations, Garrett. Our second winner today is Hugo M. Congratulations, Hugo. Our third winner today is Daryl J. Congratulations, Daryl. And our final winner today is Martin C. Congratulations, Martin. And congratulations to everybody. And check your inbox for your $25 Amazon gift cards. If it's not there in the inbox, check your spam folder. Will, thank you so much for such a great presentation. Lots of really fascinating stuff. Love the demo. All good stuff all the way around. So thanks again. Really appreciate your time and your expertise. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody. Please stay safe.